Hey everyone, welcome to another episode of BlockHeads, where in this episode, we're going to be creating the Decentralized Venmo App I like to call Dcash. We're going to do things a little bit differently in this episode. We're just going to be focusing mostly on the smart contract and not the front end. If you're interested in joining us for a live workshop, then please sign up in the description below. We're going to have a form for that. If you guys want to go over making this full application, you guys can ask me any question you guys want to live and on the spot. But for now, we're going to be building out the smart contract for a front end I already finished, and you guys can go ahead and go over to GitHub and download that front end for yourself. And with that, let's jump right in. So hi guys, I'm going to give you a quick overview of the front end you can get from GitHub in the link in the description below. Just go ahead and copy and clone the repo into the destination of your choosing. So this is the simple send money tool. Here's your recipient field. The field you have to enter your near value in to be able to designate the value or amount of near you want to send to your friends, and something to type into the memo. It gives you an error saying that you need to type something into the memo field to be able to send money to your friends. Just say hi. If I send something here, we're going to get an error back, because today what we're going to be doing is going to be building up the Rust smart contract. So we see that this method does not exist because we have not typed in that method yet. Go over to transactions. We're going to also see an error here because we rely on the blockchain to be able to provide us with the information that contains our list of transactions. So that's what we're going to be doing today. We're going to be filling all that out. And again, you guys can clone this front end from GitHub and follow along after you do that. So yeah, let's keep going. Okay, so before I begin, I sincerely encourage you guys to sign up for our workshop. It's gonna be a live workshop. We're gonna be rebuilding Dcash from the ground up, front end and all. So you guys wanna figure out how to build out this full application, sign up for our workshop. So jumping right in, I'm right in the lib.rs in the contract folder, and I'm just going to get rid of a few things. I'm going to get rid of this thing. I'm going to get rid of records, anything that's to do with records, essentially. We're going to get rid of it. We're going to get rid of everything inside this implementation, except for the curly braces that help, build it up. And then all these comments going down here, all the comments on all the tests, don't need any of that. So just going to get rid of it all. Going to hit save, going to let that, kind of reorganize itself. Every welcome you see here, we're just going to switch it out with Dcash. You can name welcome to be whatever it wants. It's just a welcome file. We're going to actually import two things. We're going to import from your SDK, we're going to import account ID, and we're also going to import promise. Account ID is just a type definition, so it's the same thing as writing the word string, but sometimes the naming convention is nice. So we're just going to call it account ID. And promise, it contains a method that we're going to use to be able to send money using our smart contract. So the very first thing that we're going to do is define our lookup map. So we're going to go over to struct, and type in memo. So memo is going to be the name of the property that holds our lookup map. A lookup map is kind of like a key value pair, sort of like kind of like a simple any map you'd find in like Python or something, or like an object in JavaScript. Lookup maps are pretty efficient, more efficient like hash maps. We have a cool little demo describing all of our collections. I can also link in the description for you guys. So moving on from that. So our key is going to be defined as a string, and our values are going to be vectors of strings. So vector string, there we go. And going into our actual implementation, actually before we even do that, we still have one more thing to do. Yeah, right here where it says default is default return self. So right here we're gonna define memo lookup map new b memo, and get rid of that first quotation mark. That was a mistake. And we're gonna say dot to vec. So this looks really confusing, really stupid, I know. But essentially what's happening is we're turning this string called memo into bytes. So if you see this last thing here, this b memo here, this is the output we're getting. We're getting that entire string, every letter, every character as a byte. So 109, 101, 109, 111. That's what's being sent to the blockchain to be the unique prefix that this lookup map will need. So if we have multiple lookup maps, like they're all going to have different prefixes so that there's no data collisions. So moving on from that, we're going to begin creating our change methods and our view methods. Remember, the difference between a change method and a view method is a change method, change method, they incur a fee. So every change method incurs a fee by changing the state of the blockchain. So remember that. They incur a fee by changing state of the blockchain. That means adding information or changing information to and from the blockchain. So change methods. We're going to go here. We're going to have two change methods, one called one called add memo, and the other one that we're going to call transfer money. We're not going to create that one yet. So add memo, mute self. We'll start with mute self. That's the first parameter. You have to add that mute to every single change method you create. Remember that. So mute is going to be able to allow you to change the, change the state of the object that we are creating. So we have mute self memo underscore text. If you're creating a view method, we don't include mute. You don't make the self object mutable. Just want to make that point clear. Memo underscore text. If you don't put underscores, you put camel case, it's going to scream at you. Like it's going to give you like a bunch of warnings. You compile Rust. So be sure to use this like underscore format here. So this underscore format is what you want to do every time you're writing a variable or every time you're naming a function inside Rust, or else it'll give you like a string of warnings and it'll be kind of annoying. You're going to be like, what's going on? And be like, well, Dorian told me so. Anyway, so moving forward, so we have, memo text, account ID, and we're also going to add this other variable called amount. So amount, and we're going to just leave this as a string. There we go. So this was in my original code, so we're going to have to go into our front end a little bit and modify our front end to accommodate for amount underscore string. Actually, I think we can change that right here. I'm sorry. Instead of amount, let's just switch this name to price. There we go. You don't have to change anything in the front end. Cool. Okay, so we have two parameters: memo text and price. So let's keep it going. We keep moving forward. We're gonna create one variable here called let account underscore ID equal to env. That's I believe that's something we get from Near SDK up here. So that's where env comes from the Near SDK. Env, inside this env crate, we're going to pull out signer underscore account ID parentheses. That's going to give you the last ID of the person that signed a transaction for the smart contracts. In other words, it's going to give you the name of the person that's currently signed in who initiated this smart contract call or this contract call. So moving forward from that, we're going to say let contains user. This is going to contain a Boolean value. So contains user is equal to self.memo. So again, self.memo. Remember, we define memo up here. That's memo is referring to a lookup map that contains a string and a vector of strings, a vector of strings. And if you don't know what a vector is just like an array that's resizable. So you actually have to use this thing called a vector to make a resizable array in Rust. It's a little bit weird because like you can't just use an array, but just let you know there that's there. So we have memo.contains key. Contains key is going to look for the name of the account that's currently signed in that we store in that variable account underscore ID. So account underscore ID. There we go. Semicolon to conclude that line there. Moving on, we're going to use that new Boolean we created to implement that into an if statement. The if statement is going to check if a user currently exists within the lookup map that we defined earlier, meaning that they actually have existing memos. Because we're storing all of our memos into that array and corresponding each memo with a particular user. So we have if contains user. We are going to create if the lookup map does contain a user, we're going to create a lookup map. We're going to create a temporary array that contains that vector of strings that goes with that user. So let's just call this let mute temp list is equal to match self.memo.get ampersand account underscore ID. So now this is going to be the weird part, right? So why do we have to use like this sum and none statement? Like, why? This looks so weird to me. Why not just like get the array and be done with it, right? Or get the vector and be done with it. So this get, if I hover my mouse over it, you're going to see that it actually returns an option. So an option is kind of like a switch statement in JavaScript, where you have these two keywords called sum and none, meaning if the option does return some value, right, you'll have to use this like sum action. So the sum action could be anything. It'd be like if something exists, print ln x. That just means like throw this value that's retrieved and print it to the command line. Or it could be like, I don't know, return x, but like add 3. It could be anything, right? You're just returning some action to this variable here, temp list. If none, it says do this thing, which is going to be returning an empty array. Meaning like if nothing returns, but there's going to be something because we checked for that already. So now we have so now just know that this is going to return this x value. This x value is going to be like the vector of memos. So x is the vector of memos. Just keep that in mind. So moving forward, we're going to have temp list.push. We're going to be pushing in memo underscore text plus, so memo underscore text, remember, is a string. So we're going to add a space. We're going to add these two cool little pipes here. Add space.
That's what I figured.
Sorry, I hate Siri. Plus the price. So we're adding on the price, which is a string, to the text memo and separating them by these two pipes. Then we're going to add the word near. And oh yeah, price is giving me an error because we have to it's that we can't just like call the variable. We have to actually reference the value within it, which doesn't really make sense and why this isn't actually returning an error too. Actually don't know why memo text is working like that. But okay. If you know why, then let me know, because I literally don't know why it's not giving me an error there. It should be. Self.memo.insert. So now we're going to actually have to add this newly modified temp list array to the blockchain so we can actually save our new information to the blockchain. So we're going to say self.memo.insert account underscore ID. And the value will be, guess what it is? It's going to be temp list. Remember, this ampersand in front, and we're going to include that. This ampersand in front of these variables references the value located at the memory location of that variable. It's a little bit weird. So we can't just call the variable name itself. You have to actually reference the value within it using the ampersand. And if you know what ampersand is, that's what this symbol is called. So moving forward, that's our entire if statement. Let's type in our else statement. So we're going to have else if contains user does not return positive, meaning that there is true, meaning that there is no vector of memos associated with the user that's signed in currently who's trying to add a memo. We're going to create a fresh vector. A fresh vec should be equal to the vec macro. That's what this little thing is called, the vec exclamation point. This allows you to create vector instances if you're not used to Rust. And in which we're going to include memo text and copy everything you see up here, everything up to this first plus sign, just like this. So we can just slap that onto this memo text here, so that we don't have to like add later. So that'll automatically append the price, the amount of money we're sending to our friends. So now we create a vector instance, which will just be the very first memo with the very first price added to this vector. So moving on, after we create this vector, we're gonna simply add it to the blockchain. So self memo insert account underscore ID, and we're going to be adding ampersand fresh vec colon. So the semicolons, remember, they conclude that line. And I want to point that out for a reason, which will come up when I create the view method. But just want to kind of put that in your brain now, put a little C in there now. So that's it, save it, it all formats for me. Next function will be the function that we're going to be using to send your tokens to other people. So remember earlier we imported this like promise struct from this like NearSDK crate. I'm still getting used to the Rust lingo, so bear with me. Pub function transfer money. So we're going to call this transfer money. Transfer money, we're going to have a mute. So this is another change method. So every change method you write, you have to have mute self in order to modify the struct. Account ID. So account ID will be account ID, which is the same thing as writing string here. You could literally write string, it'll work the exact same way, but we're importing account ID from the NearSDK, so we can have our types defined and properly organized. So we're going to leave as account ID. And then mount, the numbers that we're going to be throwing into here will be of type F64. We are not returning anything, so we're not going to define that. And this is a single line function. It's really easy. So it's promise new account ID, and we're going to be sending this new account ID. Oh, go away. Which again is just a string, right? It's nothing fancy. This is just a string. Could be anything. Could be Dorian. We're going to be sending this account ID. Here we're transferring some amount, in which that amount variable it will be redefined to a U128. I think, fun fact, JavaScript can't actually use U128, so we're importing it as F64, and I think this uses U128. And it's saying I have an error somewhere. Promise new account ID dot transfer amount. Sorry, not of, as U128. And that's it. That is literally the line that you need to use to be able to transfer money in Rust, and directly in your Rust smart contract. There's a way to do it for AssemblyScript as well, and there's also a way to do it using Near API.js if you want to be able to transfer money using JavaScript. But this is how you would do it with Rust, or this is one way you can do it with Rust. I think there's another way as well. View methods. So view methods incur no transfer fee from the blockchain. It's just mainly used to read information from the blockchain. So you just can use them as much as you want, and you don't get charged. And another thing that's different about them, we're gonna name this method get memos. The other thing that's different about them is that they do not use the mutable keyword. If you don't use this, I think you do get an error. I'm sorry, if you do use this for a view method, I'm pretty sure you get an error, but we're not going to find out right now. But you don't need to use them for view methods. So do not make self mutable in a view method. User string. So that's all we need. We're just going to be using this method to get our array of memos from the blockchain. Vec string. So this little arrow here, that's going to be defining the type, the variable type, or the data type that we're going to be that this function will be returning. If the function does not return this data type, it will return an error. So match self.memo.get ampersand user, ignore that caret, in fact delete that caret, sum x. So again, we're using this like sum statement. Think of it like a switch statement in a way. If we have something, we're gonna return x, whereas x is a vector, that contains all your memos. So this is a vector that contains all your memos. Otherwise, this will return an empty vector. That's all that's happening here. So this will literally end up looking like memo1, comma, memo2, etc. Right? So this is literally like what this will return, or this will return like that. So now, how do you define a return statement in a function in Rust? You simply omit a semicolon. So a semicolon is how you conclude a line. This will be valid if I had nothing here. So no errors anywhere. This is fine. This is completely legal here. But because I'm saying I want a vector of strings, I have to omit this semicolon, and that's how you tell this function to return this value. So again, to return a value from a function in Rust, just simply omit the semicolon. And that's really it. All these function names are defined in utils.js already for you in the front end code. Like I said earlier. Again, if you want me to go over the entire front end code, be sure to join the live workshop. Just type in your availability inside the form that we created for this, and we can get through making the entire front end. But let's just, before we go on with all that, sorry, just getting ahead of myself. Let's see if this works. So we're gonna type in yarn build. So every single change you create, every single change you make to a smart contract, you have to rebuild your smart contract because you are recompiling it. It's not like an interpreter. You can't just save. You have to actually recompile everything and then send that off to the blockchain, or send it off to the RPC. So the smart contract gets updated, and then you can begin using it. Building. There we go. It's now done. So we can type in yarn start. It's deploying. There we go. Okay, so we're gonna test out our application and send example account 12345.testnet some near. So we're gonna say send 5 near for used Xbox game. I'm gonna hit send near. And we're gonna wait a little longer. We see money has been sent. We're gonna hit OK. We're gonna go over to our wallet.testnet.near.org. We're gonna hit refresh. And we can see that just now we received 5 near from this dev account, which is the contract, which is the account that the contract was deployed on. So, and if we go to our transactions page, we can see that we sent 5 near, and we can even modify this in our smart contract code to include the name of the recipient that we sent it to, which is something I probably should have done here, but it's not too hard to do if you guys want to do that. So use Xbox game for 5 near. And that's really it, guys. If you guys like this format where I'm just showing you guys the smart contract code, please, again, let me know in the comments below. I'm going to be hosting a live BlockHeads workshop. We're going to be creating our very own decentralized Venmo application from scratch on August 26th, 27th, 28th. Be sure to sign up in the Google Forms below, and hope to see you guys there. Hey guys, sorry if I look like death right now. Between making the assets for this video and going on vacation, and now I contracted COVID, unfortunately, but thankfully I had the vaccine, so I'm feeling, already starting to feel better, feeling stronger, so I'm really thankful for that. Guys, I hope you enjoyed this video. If you guys did, let me know what you guys thought in the comments below. like and subscribe. And if you make a better version of this account application or any of the other applications we make in our tutorial videos, send it my way via the Discord channel. You can find me in Discord and we can make a really cool community video together. So send me your version of Dcash or your version of any of these applications, and let's just make an awesome BlockHeads video together showing off what you guys create. I think it'll be beautiful. I think it'll be a lot of fun. I'm really excited for that. Other than that, guys, thank you so much. Remember to like and subscribe, and have a great day.